Hello students. So in this video we will discuss a very interesting topic, primitive roots. So here the name of the topic is primitive root modulo n. So first of all, the definition: if GCD of a and n is 1 and a is of order phi of n modulo n, then a is called primitive root. A is a primitive root. Of integer n. For example, let n is equal to 3. Now first of all, we have to choose those numbers a which are relatively prime to 3. And we know only two numbers are relatively prime to 3, 1 and 2. And then we have to calculate phi of 3. And very easily, number of integers less than equal to 3 and relatively prime to 3 are again 2 in number. Then out of these two, primitive root of 3 is whose order is 2. And very easily we can see that 1 is concurrent 1 mod 3. So how much is the order of 1 here? 1, because power 1 make it 1. So it cannot be a primitive root. Now we check for 2. 2 is concurrent 2 mod 3. And then we raise power on both sides, 2 square. And here we get 4. And very easily 4 is concurrent 1 mod 3. So this means that order of 2 modulo 3 is equal to 2, which is further phi of 3. Hence, 2 is a primitive root of 3. So I hope you got an idea what is primitive root. Let us have one more example for n is equal to 4. Now very easily we can write the numbers which are relatively prime to 4. What are those? 1 and 3. And also from this we can write phi of 4. That is also 2. Now out of these two, primitive root of 4 is whose order is this much. So as again 1 cannot be a primitive root because order of 1 is 1. Let us check for 3. 3 is concurrent 3 mod 4. And how much is 3 square? That is 9. And very easily 9 is concurrent 1 mod 4. So from this we can write order of 3 modulo 4. How much? 2. That is phi of 4. Hence, 3 is a primitive root of 4. The next question that comes to our mind is, how many primitive roots modulo n are there? Now to answer this question, we again revise some results. As for a number to be primitive root, GCD of a and n is 1. And also we know that a1, a2, a phi n is a reduced residue system modulo n. Means all of these are inconcurrent to each other. And because of this, and a is relatively prime to n, then a power 1, a power 2, a power phi n is also a reduced residue system modulo n. So they are also inconcurrent to each other. Means to say a power I GCD is also 1 for I from 1 to phi n. And also we know if order of a modulo n is k, that is a power k is concurrent 1 mod n, then order of a power h is k divided by GCD of h and k. Now using this property, we can easily write that order of a power h is same k if and only if this GCD of h and k is 1. If this denominator is 1, then order of a power h is also equal to k, which is same as order of a. Now we make use of these results for primitive roots. So let me discuss. Let a is a primitive root. A is a primitive root. That means GCD of a and n is 1 and order of a is phi n. This is concurrent 1 modulo n. Now very easily, what other power of a is a primitive root? Very easily we can check that when the order of a power I is also phi n 1 mod n. So we make use of this result here, that order of a power h is again k when GCD of this power and k is 1. And look here, how much is the power here? I. And how much is the order? Phi of n, when GCD of I and phi of n is 1. And where I lies? I is from 1 to phi n. Now just read it as we learn the definition of Euler function. Number of integers less than equal to phi n relatively prime to phi n. So I'm again repeating, number of integers less than phi n relatively prime to phi n. How many they are? Phi of n. So this is a very important number. So what this gives us? Total number of primitive roots modulo n. So this gives us total number of primitive roots modulo n. Let us see its applications in the form of numerical. For n is equal to 7. Now question is, find all the primitive roots of 7. So for this, first of all, we write those numbers which are relatively prime to 7. As 7 is a prime, so all the number less than 7, 1, 2, 3, 4, 5, 6 are relatively prime to 7. And how much is phi of 7? It's 6. And very easily we can write how many total primitive roots are there. So we put value of phi 7, that is phi of 6. Now we have to write phi of 6, number of integers less than 6, relatively prime to 6. How many they are? 1 and 5. So only 2 numbers. That means 7 has 2 primitive roots. And what are those? They may be any two of from these numbers. Out of these 6, 2 numbers are primitive roots of 7 having order 6. Let us try finding them. So as earlier, 1 is out of this because order of 1 cannot be 6. Let us start from 2. 2 is concurrent 2 mod 7. 2 square is concurrent 4 mod 7. And 2 cube, it is 8. 8 modulo 7 is 1. So how much is the order of 2? Order of 2 is then 3. So it cannot be a primitive root because we want its order should be 6. So 2 is out of this. Let us check another number, 3. 3 is concurrent 3 mod 7. And 3 square, 9 mod 7 is 2. And very smartly, we see we are getting 2 here. So what power should we raise here so that it becomes 1? And we are taking modulo 7. So that means when we raise power 3 here, so it is 8. 8 modulo 7 is 1. So raising power 3 on both sides. So 3 power 6 is concurrent 8, which is further concurrent 1 mod 7. That means order of 3 modulo 7 is 6, which is phi of 7. Hence, 3 is a primitive root of 7. So this is one primitive root. Now we have to find second primitive root. Now there are two methods. One is that similarly we will keep on verifying. We will check for 4, 5 and 6 which has order 6. Now there is one shortcut method with which if we know one primitive root, we can find all other primitive roots. Now let us discuss that shortcut method. Now as we know 3 is a primitive root, that means 3 power 1, 3 power 2, 3 power 3, 3 power 4, 3 power 5, 3 power 6. This form a reduced residue system modulo 7. Means to say all these powers are relatively prime to 7 for I from 1 to 6. Now as earlier I discussed in the definition what power of 3 has order same as that of 3. What power of 3 has order same as that of 3, that is when GCD of I and 6 is 1 for again I from 1 to 6. So what are the possibilities for I now? So I may be 1 and 5. Only two numbers are relatively prime to 6 here. Hence, what are the primitive roots then? 3 power 1 and 3 power 5. So we already know that 3 is a primitive root and 3 power 5 we will further solve, and 3 power 5 comes out to be, let us write it this way, 3 square into 3, that is 9 is to 9 is to 3 modulo 7, which may further simplifies to 9 mod 7 2 is to 2 is to 3 mod 7, and this is 4 3s are 12. 12 mod 7 is 5. Hence, primitive roots are roots of 7 are 3 and 5. Answer. So I hope you got an idea. First of all, we have written all the possibilities. Then how we go for next step? By choosing a number and checking its order. If it is 6, it's a primitive root. And once we know one primitive root and we know total number of primitive roots, then we write like this and choose those powers which are relatively prime to 6. So this will give us all the primitive roots. Let next number be n is equal to 10. Question is, find all the primitive roots modulo 10. Then first of all, we write those numbers which are relatively prime to 10. What are those? 1, 3, then 7, 9. So very easily, how many they are? Phi of 10 is 4. So out of these 4 numbers, primitive root is whose order is 4, modulo 10. Now how many total primitive roots are there? Phi 10. We already have phi 10, that is phi of 4. And how much is phi 4? What are the numbers less than 4 and relatively prime to 4? Only 2, 1 and 3. 2. So that means total 2 primitive roots are there. So let us start finding. 1 cannot be primitive root. Start from 3. Second option. 3 is concurrent. 3 mod 10. 3 square is 9. And 9 is minus 1 mod 10. Now again squaring both sides. 3 power 4 is concurrent. 1 mod 10. So that means order of 3 modulo 10 is 4, which is actually phi of 10. 3 is a primitive root. Of 10. So this is one primitive root. But there are 2 primitive roots. Now we use same method, shortcut method. So as we know, 1 primitive root, that means 3 power 1, 3 power 2, 3 power 3 and 3 power 4. So how I have written 3 power 4? Up to the power phi 10, and phi 10 is 4, is a reduced residue system modulo 10. That means 3 power I is relatively prime to 10 for I from 1 to 4. Now we have to find that power whose order is same as that of 3. So for that, again we use that result. If order of A is k, then A power h has also order k if and only if GCD of h and k is 1. So we make use it here again. Now we want GCD of I and 4 is 1 for I from 1 to 4. What are the possibilities? I is equal to 1 and 3. That means 3 power 1 and 3 power 3 are the primitive roots. So 3 we already have. And how much is 3 power 3? 27, which is concurrent 7 modulo 10. Hence, primitive root of 10 are 3 and 7. Answer. Next number, n is equal to 13. Now here, as we know, relatively prime number to 13 are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So very easily we can write phi of 13 because 13 is a prime. 12. All the number less than 13 are relatively prime to 13. And how many total primitive roots? Phi of 13. That means phi of 12. Now very easily we can write phi of 12. Either you can write the numbers or you can use the formula. This is 2 square into 3, as phi is multiplicative. This is phi of 2 square and into phi of 3. And phi of 2 square is 2 square minus 2 and phi of 3 is 2. This is 4 minus 2 is to 2, that is 4. So means there are total 4 primitive roots of 13. And they are the 4 out of these 12. Out of these 12, 4 are the primitive roots. So we know we have to find only one and we can write others from that primitive root. Let us start with 2. 2 is concurrent 2 mod 13. And 2 square is 4. 2 cube is 8. mod 13, and 2 power 4 is 16 modulo 13 is 3 modulo 13, and 2 power 6 is concurrent. 4 is to 3 12. 12 means minus 1 mod 13. How can we make it plus 1? Again, squaring both sides. So it becomes 2 power 12 concurrent 1 mod 13. So very easily, how much is the order here? Order of 2 modulo 13 comes out to be 12. This is basically phi of 13. Means 2 is a permittive root of 13. Now let us find other primitive roots. For that, first of all, we write all the powers I from 1 to 12, 2 power 1, 2 power 2, 2 power 12. Here, as we know, GCD of 2 power I with 13 is 1 for I from 1 to 12. Now again, using the same method, if A has order k, A power h has order k, if and only if GCD of h and k is 1. So here, how much is the order required? 12. Order required is 12. That means order of 2 power I is 12 if GCD of I and 12 is 1 for I from 1 to 12. Then what are the possibilities for I to be relatively prime to 12? 1 and 5, 7, 11. So these four numbers are relatively prime to 12. That means primitive roots are 2 power 1, 2 power 5, 2 power 7, 2 power 11. So 2 we already proved. Now write 2 power 5, that is 32, which is further 6 mod 13. And 2 power 7 means we multiplying by 4 on both sides. 6 4s are 24, and 24 modulo 13 is 11. Next is 2 power 11, means we are multiplying by 2 power 4. 2 power 4 means 16 is to 11 modulo 13, which is further 16 modulo 13, 3 is to 11 mod 13, and this is 33. 33 mod 13 is 7 mod 13. Hence, primitive roots of 13 are primitive roots of 13 are 2, 6, 7, 11. Answer.